So welcome to our revision tutorial, just looking at the reactions of the group 1 elements and key reactions that you will have seen before when in school and ones that you need to be familiar with. And one of the common ones is the reaction of the alkaline metals with water. So we're just going to go through 3 of the alkali metal reactions with water and show how they follow a similar pattern. So our first one is the reaction of lithium with water to form lithium hydroxide and hydrogen. And underneath you've got the balanced symbol equation showing chemical symbols for each of those compounds, and as well as that, the state symbols showing that lithium is a solid, water is obviously a liquid, lithium hydroxide is an aqueous solution, so the lithium becomes dissolved in the water, along with hydrogen, which is a gas. Okay, now when you'll have seen this before in school, it will have been your teacher demonstrating and placing a small piece of the alkali metal onto water and seeing what happens. Now, first thing to obviously bear in mind is that when you've got lithium, one of the common signs of the reaction is that you put it onto the water and it fizzes. Now, the reason why it fizzes is it's producing gas. And as we can tell from the equation, that gas is hydrogen. Now, that gas allows a piece of lithium to move quickly across the surface of the water. Sort of buzzing around, if you remember having seen this before. Now, the other reason is that it stays on the surface of the water is the low density that it has. It means that the density of it is actually lower than the density of the water that it's been placed in, which allows it to float. Good. And as well as that, as we've said, the lithium hydroxide that's produced is an aqueous solution, so it's become dissolved in water. Now, one of the indicating signs that it's become dissolved in water and it's formed an alkali is that if you place a universal indicator into the water once the reaction has occurred, it'll tell you that the solution has got a high pH value, so it'll have lots of hydroxide ions in it because the universal indicator will turn purple. Good. So that's our first reaction. Following on with that, sodium in water follows a similar pattern in terms of our equation. Sodium plus water gives you sodium hydroxide, an alkali, and hydrogen gas. Now, as well as lithium, we also are able to tell that sodium hydroxide forms an aqueous solution because, again, if you put universal indicator into it, it will show that it's got a high pH by turning purple. Good. Now, sodium in reaction compared to the lithium is more vigorous. Okay, so sodium actually forms and melts into a ball shape as it moves around the surface of the water and it floats. But due to the amount of gas it produces, it also moves quicker than the lithium because it's producing more gas bubbles. Good. And because it's producing more gas, we've got more fizzing. Which, if we've got more fizzing, tells us that we've got more hydrogen. So overall, the reaction is more vigorous because, as we've discussed in previous videos, because the valence electron on the atom, each of the sodiums, is further away from the nucleus, it means it's easier. It means it's easier for it to lose that outer electron and therefore react more easily. And following on in that similar vein, we then have potassium. Following again, same pattern, potassium plus water gives you potassium hydroxide plus hydrogen. Now, because potassium is more reactive, the reaction is even more vigorous because it's easier for those potassium atoms to lose their outer electrons. So the potassium itself actually combusts and produces a lilac flame on the surface of the water. Produces a lilac flame on the surface of the water because it's very reactive. This is very reactive. So the hydrogen that's produced, because there's so much of it, actually ignites. And that's the cause of it combusting into flame. And the reason why it's purple, is because of the structure of the potassium ions. So the potassium ions cause purple flame. So those are 3 examples of common reactions of alkaline metals with water that you might have seen in class environments demonstrated to you. As well as that, we also want to be familiar with how group 1 elements react with oxygen. Now, whenever you've got a group 1 element reacting with oxygen, you form a metal oxide, and the name of this process is oxidation. So the name of this process is oxidation. Now, as we've said before, in terms of the properties of these metals, alkaline metals are often shiny and pure, and you find that they're kept in oil to prevent reacting with oxygen in the air. But when they are removed, from oil and they start to react with oxygen that's found in the air, oxidation reaction occurs and we have a metal oxide, which basically means we go from a shiny pure metal to a metal that's kind of dark grey and what you might describe as tarnished, because a layer of metal oxide molecules is formed on the outside. Good. So that's our reactions of our group 1 elements with oxygen. And then finally, it's worth considering what happens when we heat group 1 elements in air. So, similar to our other reactions, when we do this, the reactions of each of the elements get more vigorous as you go down the group. So obviously heating the metal using a Bunsen burner, and what happens is you then put it into a gas jar full of oxygen. And as you put it in, because there is more oxygen available, it means that your heated metal burns even brighter. burns even brighter because it's got access to more oxygen. Now, in a similar manner, because oxygen is in the air, you are carrying out an oxidation reaction. So if you were to use our three elements from earlier, lithium plus oxygen, this process of burning lithium in the air would form lithium oxide. Sodium plus oxygen would form two substances, sodium oxide and sodium peroxide. She's got extra sodiums and oxygens per atom, okay? Na2O2. And as well as that, if we did the same with potassium, potassium plus oxygen would form potassium oxide and a substance called potassium superoxide. So potassium oxide has symbols K2O2 per molecule. And potassium superoxide has more oxygen than it does potassium because it's KO2. Now, it's also worth just noting down that the same principles apply when reacting and when burning alkali metals in chlorine. So the same principles apply when burning in chlorine. So you might have an example of potassium being heated and burnt in chlorine gas would form not potassium oxide but potassium chloride. So there is our tutorial on reactions of group 1 elements. So hopefully you found that useful.